الرحمن الرحيم. أعزائي طلبة الثالث المتوسط في تمريض التمييزين في نيسان، السلام عليكم ورحمة الله وبركاته. درسنا هذا اليوم هو ربط المقاومات على التوازي. The title of the lesson: Parallel connection of the resistors. This diagram represents the electric circuit connection in parallel. This R1, R2, and R3, this battery electric K and connection Y. When it close the electric K, the electric current flow in the circuit. The electric current in the circuit divided to three parts. This I1, I2, and I3. I1 represents the electric current flow in the first resistance. I2 represents the electric current flow in the second resistance. And I3 represents the electric current flow in the third resistance. Potential difference of the battery represents the total potential difference of the electric circuit. Now, V total, the total potential difference of the electric circuit equal V1, V2, V3. This is because all the resistance is directly connection with the battery. I total equal I1 plus I2 plus I3. But I equal V divided by R. Substitute this equation in equation 2. This equation 1 and this 2. I total equal V total divided by R equal I1 V1 divided by R1 plus I2 V2 divided by R2 and I3 V3 divided by R3. V total divided by R equal, in the first equation, V total equal V1, V2, V3. Now, by take the common factor, V1 divided by R1 divided by R2 and R3. Divided two sides of equation on the potential difference. Cancel V total with V total. R1 divided by R equivalent. 1 divided by R1, R2, and R3. This equation to calculate the V total, I total, and R equivalent. Notes. Number 1, to calculate the equivalent resistance, use either 1 divided by R equal R1, 1 divided by R2, and 1 divided by R3, or R equivalent V total divided by I total. These two equations to calculate or to find the equivalent resistance. 2. The equivalent resistance of parallel connection is smaller than any resistance in the circuit. 3. To calculate the potential difference, use V total equal I total times R equal, or V equal I times R. to calculate the electric current used. I total equal I1 plus I2 and plus I3, or I total equal V total divided by R equal. Attention student, this notes must be right in the cup. Example in page 46 in book. By observing the diagram, R1 6 ohm, R2 9 ohm, R3 equal 18 ohm, V total 18 volt. Calculate number 1, R equivalent, number 2, I1, I2, and R3, 3I total. 1 divided by R equal 1 divided by R1, R2, and R3. 1 divided by R equal 1 divided by 6, 9, and 18. By take the common multiple from this number equal 18. 18 divided by 6 equal 3. 3 times 1, 3. Plus 18 divided 9 equal 2. 2 times 1, 2. 18 divided by 18 equal 1. 1 times 1 equal 1. 6 divided by 18. R equivalent 18 divided by 6 equal 3 ohm. V total equal V1, V2, V3 equal 18 volt, because the connection in parallel. Now, I1 equal V1 divided by R1. 18 divided by 6 equal 3 ampere. I2 equal V2 divided by R2. 18 divided by 9 equal 2 ampere. And I3 equal V3 divided by R3. 18 divided by 18 equal 1 ampere. Now 3 I total equal I1 plus I2 plus I3. I1 3 and I2 2, I3 equal 1, 3 plus 2 plus 1 equals 6 ampere. This amount or magnitude of the total electric current in this circuit. Problem 2 on page 52. This problem, by observing the diagram, calculate number 1, the amount of equivalent resistance for all resistance which are connected in the electric circuit. B, the amount of potential difference at the two ends of each resistance. And C, the amount of current which flow in each resistance. Formation given: R1 3 ohm, R2 6 ohm, and R3 9 ohm. I total equal 11 ampere. Number 1 divided by R equal 1 divided by R1 plus R2 and R3. 1 divided by R equal 1 divided by 3, 6, and 9. By take the common multiple equal 18. 18 divided 3 equals 6. 6 times 1, 6. Plus 18 divided 6 equal 3. 3 times 1, 3. Plus 18 divided 9 equal 2. Times 1, 2. 1 divided by r equal 11 divided by 18. R equivalent 18 divided by 11 ohm. This amount or magnitude, the equivalent resistance of the electric circuit. This, number 1. Number 2, the amount of potential difference at two ends of the electric resistance. 2. V total equal I total multiplied R equivalent. I total equal 11 times R equal 18 divided by 11. Cancel 11 with 11. V total equal 18 volt. This amount or magnitude V total. V total equal V1, V2, and V3 equal 18 volt because the connection in parallel. Number 3. Number 3, calculate the electric current flow in each resistance, I1, I2, and I3. I1 equal V1 divided by R1. V1 equal 18 divided by 3 equal 6 ampere. I2 equal V2 divided by R2. 18 divided by 6 equal 3 ampere. I3 equal V3 divided by R3. 18 divided by 9 equal 2 ampere. To check the solution, I1 plus I2 plus I3 must be equal I total. I1 6 plus 3 equal 9. 9 plus 2 equal 11. 11 is the total electric current. Now, in page 50, question 1.4 in page 50. The amount of electric current which flow in the resistance in the electric circuit given below equal. This, the diagram of the electric circuit. This R1 and this R2. I total equal 2 ampere and I1 equal 0.1 ampere. Calculate I2. Attention. I total solution. I total equal I1 plus I2 because the connection in parallel. I total equal 2. I1 0.1 plus I2. 0.1 transfer to other side, positive convert to negative. I2 equal 2 minus 0.1. 2 minus 0.1 equal 1.9 ampere. This magnitude, the amount, or magnitude, the electric current flow in the second resistance. Question 1.5 in page 51. If the reading of a meter which is connected to the electric circuit in the diagram is 6 ampere, the reading of a meter represents the amount of electric current. I total equal 6 ampere. Then the reading of a voltmeter, this circuit equals reading of voltmeter represent the amount V total in the electric circuit. Solution حل. In the beginning, to calculate the amount or magnitude, the total potential difference must be the amount of electric current and the amount of the equivalent resistance. 1 divided by R equal 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. 1 divided by 2 divided by 3 and divided by 6. Now, by taking the common multiple on this number equal 6. 6 divided by 2 equal 3. 3 times 1, 3 plus 6 divided by 3 equal 2. 2 times 1, 2 plus 6 divided by 6 equal 1. 1 times 1 equal 1. 6 divided by 6. R equivalent equal 1 ohm. This amount of the R equivalent. Now, to calculate the total potential difference, V total equal I total times R equal I total is 6 ampere. Multiply R equal is 1 ohm, X equal 6 volt. This amount the total potential difference on the electric circuit. Now, attention. Question. 3 resistance. 5 ohm, 10 or 15 ohm, and 30 ohm. This 10 ohm. Are connected in the parallel, and they were connected to the two ends of the source voltage. The electric current in the first resistance equal 3 ampere. Calculate. Number 1, the equivalent resistance. Number 2, the total potential difference. And 3, the electric current flow. And the second and third resistance. Information given. Information given. Attention skill. 3 resistance 10 ohm, 15 ohm, and 30 ohm are connected in the parallel. The type of connected or connection in parallel. And they were connected to the two ends of the source voltage. The electric current in the first resistance equal 3 ampere. Calculate the equivalent resistance, total potential difference, and the electric current flow in the second and third resistance. R1 equal 10 ohm, R2 equal 15 ohm, R3 equal 30 ohm, and I1 equal 3 ampere. Solution. Number 1. 1 divided by R equivalent, R1, 1 divided by R2, 1 divided by R3, because the connection in parallel. 1 divided by R equal 1 divided by 10, 15, and Y divided by 30. By taking the common multiple is 30. 30 divided by 10 equal 3. 3 times 1, 3. Plus 30 divided by 15 equal 2. 2 times 1 equal 2. Plus 30 divided by 30 equal 1. 1 times 1 equal 1. 1 divided by R equal 6 divided by 30. R equivalent 30 divided by 6 equal 5 ohm. This amount of the equivalent resistance. To check the solution, the amount of electric resistance is smaller than any resistance in the circuit. Small resistance equal 10, and the R equivalent equal 5 ohm. 2. The total potential difference. V1 equal I1 times R1. I1 equal 3. R1 10 equal 30 volt. But this potential difference of the first resistance and the parallel connection V total equal V1 equal V2 equal V3 equal 30 volt, because the connection in parallel. Number 3. Number 3, the electric current flow in the second and third resistance. I2 equal V2 divided by R2. V2 equal 30 divided by R2 equal 15 equal 2 ampere. I3, V3 divided by R3. 30 divided by 30 equal 1 ampere. This solution of this equation.